All right, hey, sixth graders, and welcome back to another tutorial. Today we will be moving on to section 5 and sticking in chapter 1 here. Chapter 1 is titled Numerical Expressions and Factors. You're probably getting sick of writing this out, but get to know the chapter name and practice makes perfect. Section 5 today is titled, make sure I'm telling you right here, Greatest Common Factor. Greatest Common Factor. And our learning target for the day, pretty related to that, is I can find the greatest common factor of two or more numbers. I'll start to abbreviate here in the notes and hopefully catch on. And start today with just asking you some very common acronyms, because we'll be working with an acronym today. I'm sure you've already seen it, but starting with LOL stands for, many of you know this, laugh out loud. BRB, ooh, this one's a little bit older. Be right back in the day of MSN Messenger, when your parents would want to use the telephone, you would have to get offline off your group chat with your friends because you couldn't use the telephone because it had dial-up internet and the same time you were online. How weird would that be? So you always had to tell your friends, be right back, BRB. We'll talk to you later, TTYL. Okay, moving on. TBA. More with sports, I see this too. Be announced. BLT, one of my favorites. Bacon. Lettuce. Tomato. Delicious. Tomatoes are getting to be perfect this time of year. Last one, EST, stands for Eastern Standard Time. Here in Wisconsin, we would be Central Standard Time. Okay, so as you can imagine, we're going to be working with the acronym today of GCF. Okay, and that's going to stand for Greatest Common Factor. So just to be thinking a little bit about acronyms here, we'll be working with another acronym next section as well. Okay, moving on to a little bit of vocabulary today to get us started. It says factors that are shared by two or more numbers are called common factors. Common factors. The greatest common factor, or the greatest of the common factors is called the, well, no surprise here, greatest common factor. One way to find the GCF of two or more numbers is by listing the factors. And this is the method that I will do most of the time. So for example 1 here, this is what I like to do, but I'm going to show you another method today that works as well. Okay, so here's the list method. Find the greatest common factor using lists of factors. Find the greatest common factor of 24 and 40. So if you were to see this on your homework, use a list, make factors of 24 first and factors of 40. Remember, the factors of numbers are the numbers that multiply to get to this number. So I like to start with 1 and itself. So 1 times 24 would give me 24. Okay, then I just go on down the line. 2, is 2 a factor? Well, yeah, because 24 is even. So 2 times it would be 12 would give us 24. Keep going. 3. Does 3 go into 24? And if you don't know, you can always check using division. But yeah, 3 times 8 would give me 24. And lastly, 4 times 6 would also give me 24. So there are all the factors of 24. And then I'll also list the factors of 40. Start with 1 in itself. So 1 times 40. 40 is even because it ends in 0. So 2 times 20 would give us 40. Is 3 a factor? Is 3 divisible by 40? Not evenly, no. Okay, I'll skip that. 4. Yep, 4 times 10. And how about 5? Yeah, 5 times 8. Okay, so there are the factors of 40. Now what I need to do is I need to look and see what factors do they have in common. Okay, so I'll go through and circle the ones that they have in common, or just underline. 1 they have in common, 2 they have in common, 3 they do not have in common, 4 they have in common, not 5, not 6, 8 they have in common, 10 no, 12 no, 20 no, 24, 40 no. So then I go look and see the greatest factor that they have in common. The greatest common factor is 8. Okay, so when I write out my answer here, I would write it as the GCF, the greatest common factor of 24 and 40, colon, is 8. This would be my answer. Okay, and that's just using the list method, and that's probably one of the most common that you will see. Moving on to example 2, you can also find the greatest common factor using what we learned last section, which was prime factorization. Okay, so it says find the greatest common factor of 12 and 56 using prime factorization. Okay, so remember with prime factorization, use factor trees. So I'll make a factor tree of 12. And I'm thinking about, remember 2, 3, and 5 are good numbers to start with. So I'll do 2. 2 times 6 is 12. Circle your prime numbers. And I can break down 6 into 2 prime numbers. 2 times 3, they're both prime. And so I'm done. Let's do 56 as well. You can start with, let's do 7 times 8, because 7 is a prime number. 8 I can break down into 2 times 4. 2 is prime, and I can break down 4 into 2 times 2. Okay. Next, I'm going to rewrite the prime factorization of each number. So for the 12, the prime factorization is 2 times 2 times 3. 2 times 2 is 4. 4 times 3 is 12. And the prime factorization of 56 is 2 times 2 times 2 times 7. And then I look over to this hint and it says multiply the common prime factors. Okay, so what are the common prime factors that I have here? Well, they both have 2 and 2 in common. Okay, they both have 2 2's in common. Okay, and what I need to do is multiply them. Okay, so multiplying my common factors, 2 times 2 would give me a total of 4. So the GCF of 12 and 15 would equal 4. This method isn't as common, but it's more helpful with larger numbers. All right, picking up where we left off with the Oyos, I will do one example here, and then please do the other ones on your own. Pause the video and come back to double check you're getting it right. So I'm going to use a list here for 8 and 36. Factors of 8, 1 times 8, 2 times 4, and those are all my factors. Factors of 36, 1 times 36, 2 times 18. 3 is 3 a factor of 36? I think so. 3 times 12. 4 is 4 a factor of 46? I think so. 4 times 9. 5, no. 6, yeah, 6 times 6. I just have to write it once. All right, they have 1 in common. They have 2 in common. 3, they do not. 4, they do. 6, no. 8, no. 9, no. So my greatest common factor for 8 and 36 will be 4. All right, please pause and try the other ones on your own. Again, just for time's sake, I'm not going to show my work on all of these. Please show your work on your sheet of paper. And if you're, getting the right answer, that's awesome. If you're not, rework the problem, or if you're still confused, please ask me or maybe ask a neighbor for some guidance. Okay, hopefully you've tried them out. 2, the greatest common factor is 18. It's actually one of the factors itself. And 3, the greatest common factor is 7. Okay, here for 4, 5, and 6, again, use prime factorization. I'll probably do one of them. I'll do number 4, and then you do 5 and 6. Notice how 6 has 3 numbers. Okay, so using prime factorization can be a little bit nicer, so you don't have to make 3 lists in that case. Okay, so if I break down 20 using a factor tree, let's see, 10 times 2, circle my 2, and 5 times 2. Both 5 and 2 are prime. 45. Let's see, breaking it down using 2, 3, or 5. Okay, I'll try 5 times what number? Let's see, 5 times 9 would give me 45. Okay, 5 is prime, and then 3 times 3, and both of these are prime. Okay, I'm going to write out my prime factorization then. So my prime factorization of 20 would be 2 times 2 times 5. And my prime factorization for 45 would be 3 times 3 times 5. Okay. And if I'm looking here, I see that that they don't have any common multiplied together. So these are not common, these are not common. I just have 5 as a common prime factor. So in this case, 5 would be my greatest common factor for 20 and 45. Okay, so a little bit trickier, I think, than using the list method, but go ahead, try 5 and 6 and see what you come up with. Hopefully for 5 you came up with 2, and hopefully for 6 you came up with 15. Okay. Again, if the prime factorization way confuses you, it's a little bit trickier. That's okay. You can still use the list method, and you'll still come up with the same answer. All right, finishing up with the greatest common factor for a real life example. You are filling piñatas for your sister's birthday party. The list shows the gifts you're putting in the piñatas, and you want identical groups of gifts in each piñata with no gifts left over. It's the greatest number of piñatas you can make. Okay, so here's our supplies. Lucky sister gets 18 bottles of nail polish, 24 pairs of earrings, and 42 lollipops, okay? And we want identical groups of gifts and no gifts left over. So what we'll need to do to find the number of piñatas is find the greatest common factor, okay? In this case here, let's maybe try using the prime factorization method again, since it might be trickier. Okay, so prime factorization of 18, 24, and 42, just to get some more practice with this. Okay, 3 times 6, and 2 times 3, and there we've got all the prime factors. For 24, we could do 2 times 12, and 3 times 4, 3 is prime, and breaking down 4 into 2 times 2, and both those are prime. And then for 42, we could break it down into 2 times 21, 2 is prime, and then break down 21 into 3 times 7, and both of those are also prime. Okay, then I'm going to write out my prime factorizations. So oh, sorry, I just saw the mistake that I made. This was supposed to be 18. Sorry if that messed you up at all. So my prime factorization of 18 is 2 times 3 times 3. 2 times 3 times 3. My prime factorization for 24 is 2 times, a little messy here, 3 times 2 times 2. And my prime factorization of 42 was 2 times 3 times 7. Okay, and I'm going to look and see what I have in common here. I'm going to find the product of the common prime factors. So I've got, they all have this 2 and this 3 in common. Okay, it's not common here, not common here. So I need to find the product of them, just means multiply. So 2, oh, sorry about that. Not sure why I'm getting this funky line here. There we go. So 2 times 3 would give me a total of 6. So word problem, don't forget your label, piñatas. And don't forget your little P-I-N-A-T-A-S. So 6 piñatas so that there's nothing left over. Okay. And that's all I've got for notes today. Remember, for the this example, if you want, it is just fine to make lists. So you could list the factors of 18 and 24 and 42. And, you could say 1 times 18, 2 times 9, and so on and so forth for 24 and for 42. And you would come up with the same answer that we did for the prime factorization. It's just 2 different ways of doing it, and it's kind of up to you on which way works better for you. Sometimes when we're dealing with more numbers or larger numbers, the prime factorization way works better. But I see a lot of students doing the list method, and actually that's the method that I prefer too. So if you want to stick with that, be my guest, that's just fine. Okay, that wraps things up for the notes. We will see you later.